Right, this is a question that was requested by someone, pans and lifts. It's question 2b from that worksheet. And it's a situation where they tell us that there is a maximum tension that this string can hold of 10,000 newtons. What does that mean? That means if there's more than 10,000 newtons that this tension is required to be, it will snap and all of these people will fall to their death. And the question is, how many people can we put in the lift before they all fall to their death? So in order to deal with this, we're going to say, let's see what happens, what weight we can deal with when the T is equal to 10,000. So 10,000 is right on the edge of snapping. So if we know the weight that it can tolerate at 10,000 newtons, the tension, then we know that anything more than that will snap the rope. On top of that, it tells us that we are going up at 3 meters per second, squared is the acceleration, and there's a constant resistant force of 100 newtons. That's on top of the weight pulling it down. And that weight's going to be made up of lots of different things, and we'll talk about that in a moment. So let's do force equals mass times acceleration. So the force in the upwards direction is 10,000 minus 100 minus W, because those two are pulling it down. Now in terms of that, this is going to be 9,900 minus, and then what's the weight? Well, if we look at the question, it tells us that there is the lift itself has a mass of 250 kilograms, so we've got to include that. So that's 250 G, and then it depends how many people we've got. So if we said that N was the number of people, a typical occupant they're saying is 75 kilograms, so each of these people is 75 kilogram. So that would be 75 G times N, right? And that, some kind of alarm's just going off. And so G is obviously gravity and N is the number of people. So we can work out what that is, we can rearrange it, right? So the force is going to be 9,900 minus 250 times 9.8. So this is 7,450 minus 75 GN. And we'll leave the G in. So that's for N number of people in the lift, that's what the force will be. Now, we need to do F equals ma because we know it's accelerating. And so the force is 7,450 minus 75 GN. The mass, well, the mass is made up of 2 bits. Again, the lift, which we just said was 250 kilogram, and then the number of people. So 75 times the number of people. Here you don't need the G's. Remember, the G's are just in the force for the gravity, whereas actually in the mass you just have the kilogram values. And this is going to be multiplied by 3, right? Because the acceleration is 3 at this point. So then all we need to do is solve this equation. So we're going to expand that bracket. So we've got 7,450 minus 75 GN equals 750 plus 225N. I'm going to put all of the N's on the same side and all the numbers on the same side. So subtract 750. I'll get 6,700 equals 225N plus 75GN. But of course we can work out what that is. So 225 plus 75 times 9.8 is 960. So this is 6,700 equals 960N. So to find N, we divide both sides by 960. And we get 6.9791. Right? So that's telling us, what have we worked out, that when the tension in the rope will be 10,000 if we put in 6.9791 people. So the lift will be safe providing there is less than that amount of people. So safe, everyone survives, 6 or less people. And danger right? The lift's going to snap, it's going to break, they're all going to die if we have 7 or more people. Okay, so tricky on that, nice bit of problem solving for you, right? Having the n as the variable rather than anything else in the problem. Yeah, hope that cleared it up.